Welcome to CUET BABA. So in this today's video, we'll be discussing the part 2 of mixture and delegation. So in the part 1, we have covered a good number of problems. Now in the part 2, we'll be solving the other models that are left out, and we'll try to get a full idea or the full picture about all the type of problems that are possible in the mixture and delegation concept. Okay. So these are all the problems that we have solved starting from the basics, and we have done a good number of problems and covered good models as well. And this was the last question that we have solved. Now coming to this question, okay, we'll start from solving the question from this question. So what is the question telling? A fresh fruit contains 68% water, and dry fruit contains 20% water. Okay, so fresh fruit, so there are two types of fruit, fresh fruit and dry fruit. So fresh fruit contains 68% water, and dry fruit contains 20% water. So how much dry fruit can be obtained from 100 kgs of fresh fruit? That is a question. Okay, so there are two different fruits, fresh fruit and dry fruit. So in fresh fruit 68% is water, that means the remaining 32% will be the pulp, and in the dry fruit 20% is the water, so the remaining 80% would be the pulp. Now what is the question they're saying? They're asking how much dry fruit can be obtained from 100 kgs of fresh fruit. Okay, so that is the question. So how do we solve this particular thing? So going to the notepad, we'll solve this in notepad. So what are the things that have been given to us? So water and pulp. Okay, water and pulp. So in the first case, that is this particular fresh fruit, that is 68% water and 32% pulp. Okay, so in the case of pulp, in the case of fresh fresh fruit, so this dissolves to like 68 and 32. You can simplify that to 17:8. Okay, 17:8. Now this is for fresh fruit. Okay, this is for fresh fruit. What about dry fruit? What about dry fruit? 20% water and 80% pulp. Okay, 20% water and pulp. This this simplifies to 1:4, isn't it? So 20:8 is basically, 8 is basically nothing but 1:4. Now what did they actually mention? So while actually fruits getting dry, pulp remains the same, isn't it? So when this particular fresh to dry transition happens, when a fresh fruit is actually converting into a dry fruit, what is actually happening? The water, okay, water content water content is decreasing. Okay, water content is decreasing. That is what happens when a fresh fruit is getting converted to a dry fruit. The water content that is originally there in the fresh fruit is being decreased, so that it will come to a certain amount. Now in the dry fruit 20% water is there, in the fresh fruit 68% water is there, so the water content is getting decreased, but the pulp content remains the same. Okay, so that is the funda here. So whatever the thing that is remaining same, we'll use that as the pivot. So if I just try to simplify these two, okay, so I'll just take the LCM of what is the same thing that I've told. Pulp remains same. So what is the value of pulp in the first case? It is 8. What's the value of the pulp in the second case? It is 4. So take the LCM of these two. LCM of 8 and 4. What is LCM of 8 and 4? That is 8. So how do you get 8 from 4? Multiply by 2. So this is into 2, this is into 2. So what do you get is, you get the values like this. 17:8. This is old. Okay, this is old, and new is the dry fruit, and that is value is 2:8. Now 8 and 8 both are same. Okay, so that is the reason we are taking the LCM. Take the LCM and multiply whatever the things that are there to get to the LCM. Okay, now 8 and 8 both are same. That is what we are meant. So what did we say? Water content only will decrease from a fresh fruit to dry fruit. The pulp content remains the same. So whatever the pulp content that is there in the fresh fruit, the same number of parts of fresh content must also be there in the dry fruit. So that is the reason we are equating that pulp column. Now because we have equated the pulp column, what is the difference here? 17 minus 2, 15. Before that, we also need to see some another thing. What did they give in the question? The whole fruit, the old one or the dry fruit, the total is 100 kgs. So whatever the quantity here it is, 17x plus 8x, that is equal to 25x, that is equal to 100. From this we get x value to be equal to 4. So now with this is basically 10. So 10 into 4, that is equal to 40. So 40 kgs of dry fruit can be obtained from 100 kgs of fresh fruit. I hope you people have understood. So basically they have given the whole quantity, the original quantity of fresh fruit to be 100 kgs. So we have added water content and the pulp content and equated that to 100. From that we have got each part value to be equal to 4. And now that we have the total content of the dry fruit to be 2x plus 8x, that is equal to 10x. So we multiplied that x value with 10 to get the answer to be 40 kg. Okay, so this is how we will be doing it. So I hope you people have understood. The same thing I've written here, right? So the pulp content originally, and then in the dry fruit we have equated them and we have got the final answer. come to the next question. If the mixture of salt and water, if the mixture of salt and water, the percentage of salt is 5%. Okay, in the mixture of salt and water, it's not the if, it is in. So in the mixture of salt and water, the percentage of salt is 5%. So what would be the water salt percentage of water? 95%. Now if 80 liters of water drawn off, okay, now water has been decreased, 80 liters water has been taken out, then the percentage of salt becomes 15% of the mixture. So whenever there is 80 liters of water that has been taken out, the salt percent becomes 15% of the mixture. Then find the initial quantity of the mixture. That is the question. Okay, so it's very simple. All these are like a similar sort of questions. So what is the original salt? Like salt is to water. Okay, salt is to water. Originally it is 5 and it is 95. So this salts to be 1:19, isn't it? And now afterwards what happened? So after 80 liters has been drawn out, 80 liters of water has been drawn off, the percentage is like 15% salt and 85% water. So this is basically nothing but 3:17. Okay, so 1:19 is the first case, 3:17 the second case. Now what is that you can interpret from this? We have clearly in the question it has been mentioned that water, 80 liters water has been taken out. So what will happen to the salt? Salt remains same, isn't it? Because we are not adding salt, we are not removing salt. So the concentration of the amount of salt would remain the same. So equate the salt column. So here it is 1, it is 3. So what is LCM of 1 and 3? What is LCM of 1 and 3? That is 3. So multiply by 3 here. So into 3 here and into 3 here. So what do we get from here? We get 3:57 and we have 3:17. So what is the water change that has been there here? It is 40. And this is basically nothing but how many liters? 40x is equal to 80 liters. We get x value to be equal to 2. And now what did they ask? Find the initial quantity of the mixture. What is initial quantity of the mixture? 5 and 95 or 3 and 57. So we can just write that to be 60x equal to 60 into 2, that is equal to 120 liters. This is the original quantity of the mixture. I hope you people have understood. So originally salt and water percentage we have taken, that is 5:95, that is nothing but 1:19. And then what is the next sort of set of percentage after taking 80 liters of water? 15:85, that is basically nothing but 3:17. Now that we have got two ratios, this happened because of decrease of water, okay, but the salt concentration remains the same. The salt amount remains the same, not the concentration. Salt amount remains the same. So whatever the salt that is there in the first and second must be the same. So we have taken the values of salt in the first and second ratio, we have equated that to the LCM, and then we have got 57 in the first ratio, the amount of water, and 17 parts in the second ratio, the amount of water. Now what is the difference between them? 40. So this 40 is basically nothing but the 80 liters, because we are removed 80, 57 has come down to 17. So 40x would be equal to 18, we get x value to be equal to 2. Now what is the original quantity? 3x plus 57x, that is equal to 60x. So 60 into 2, that is equal to 120 liters. So that is the answer. Okay, I hope you people have understood this thing. Very easy. Coming to the next question, in 30 liters of a mixture of milk and water, okay, the total mixture is 30 liters. The ratio of milk to water is 7:3. To make this ratio 3:7, how many liters of water must be added to the mixture? Okay, in the question there is clear instruction that you only need to add water. You must not add milk. Okay, you must only add water. So how many liters of water must be added to the mixture? That is the question. So how do we solve this? So what is the original ratio? Milk is to water. Milk is to water. What's the original ratio that has been given in the question? That is 7:3. And what is that going to transform to? 3:7. Okay, now because you are adding water and making the ratio to be 3:7, so what is remaining the same? Milk. Okay, so the milk in the first and the second, the amount of milk in the first and the second ratio must be the same. So how do you do it? Take the LCM of these two. So LCM of 7 and 3, what is it equal to? 21. So equate this 7 and 3 to 21. How do you do it? Multiply 7 with 3 so that you get 21 in the milk. Multiply 3 with 7 so that you get 21 in the milk in the second ratio. So how did this transform to? 21:9, and this is 21:21. Okay, so I hope you people, sorry, this is not into 3, this is 7, right? Into 7. So you get this value to be equal to 49. So this is what happened. So 21:9 is the original ratio, 21:49 is the second ratio. Now what is the difference in the milk quantity? Okay, so difference in the water quantity, that is equal to 40. 40x is because how much this you need to know, that is the question, right? So okay, so before that they have given the original quantity. Okay, this is like a reverse of what we have done till now. Okay, so now we have been given with the original quantity, that is 21x plus 9x is equal to 30. From this we get x value to be equal to 1. Now what is the difference between these two? That is 40x. So 40 into 1, that is equal to 40 liters. So 40 liters of water has been added to make the ratio from 7:3 to 3:7. I hope you people have understood. So the basic concept remains the same. What is that? Equating the column that has not been changed. Okay. So in the particular mixture, we did not add milk, we added water. So the milk column must remain the same. So that is the reason we have taken the LCM of 7 and 3, and we have multiplied it the respective values with some values to get to the same value, 21 and 21. Now we have got different values in the water, 9 and 49. So what is the difference between them? 40 parts, 40x. Now we need to add the value of x. How do you get the value of x? From the first thing that is given in the question, total mixture of initial quantity was 30 liters. So 21x plus 9x would be equal to 30. So from that we get the value of x to be equal to 1. So that one we have substituted here, so that we have got the answer to be equal to 40 liters. So 40 liters of water has been added to the mixture to convert this ratio from 7:3 to 3:7. Okay, I hope you people have understood this. Very easy. Coming to the next question. The ratio of milk and water in a drum is 5:3. What part of the mixture is taken out and same amount of water is added to it, so that the ratio of milk and water becomes 3:5. Okay, so the original ratio was 5:3, the second ratio was 3:5. Now what is the first thing that you need to do in this sort of question? This add the components. Okay, so what is the component when you add in the first ratio 5 plus 3, that is 8, and in the second also 3 plus 5, that is equal to 8. Now in the question they have clearly mentioned what part of the mixture should be taken out and same amount of water is added to it. So whatever you are trying to take out and you're adding the same amount of water. So let us assume you are removing 40 liters of mixture and you will be adding 40 liters of water. So the water is being added, same amount of water is being added. So whatever the water column is there, neglected. So what is the difference in the milk? 5 minus 3, that is equal to 2. So what is the difference that is there? Divide that by the original, that is 5. Okay, so the difference that you have got is 2, right? Originally the ratio was 5:3, finally the ratio was 3:5. What is the difference in the milk? We shouldn't bother about the water, because whatever the quantity of the mixture that we are taking out, we are adding the same amount of water again into the particular mixture. So do not bother about water. Whatever the remaining column that is there, milk. So 5 minus 3, that is equal to 2. So 2 divided by the original, that is equal to 5. So 2 by 5 is equal to the part of the mixture that will be taken out, and same amount of the water will be added. So 2/5 of the water will be added, so that the ratio of the milk and water becomes the 3:5. Okay, so this is a simple technique that you can follow to solve this particular question. Coming to the next question, the same sort of approach here as well. The ratio of milk and water in a drum is 5:3. What part of the mixture is taken out and same amount of water has been added to it, so that the ratio of the milk and water becomes 1:1. Okay, so the question says like this. So the milk and water. So what is originally the milk and water ratio? That is 5:3. What is afterwards, or what is the value after? That is 1. So we have this to be equal to 8 and this to be equal to 2. What is your first job is equate them. Okay, equate the total sum. So how do you equate the total sum? Multiply by 4 here. So into 4 into 4 into 4. So what do you get out of this? You get 5:3 in the first ratio and 4:4 in the second ratio, right? I hope you people have understood. Now that we have equated this, in the question they have clearly instructed that some amount of the mixture is being taken out and same amount of water is being added. So do not bother about this column. Whatever the column that is there, apart from that column, only bother about that. Now what is the difference here? This is the milk. Okay, this is the milk, this is the water. Because water quantity is being added, the same amount of water mixture that has been taken out, so we'll not be bothering the water column. We'll only work out on the milk column. What is the difference between the first ratio and the second ratio? That is 5 minus 4, that is equal to 1. So this is equal to 1 part. Okay, this is equal to 1 part. Now what is the thing that I've told, the parts? So amount or the part, or you can write this as part. Okay, part is basically 1 divided by the what's the original, that is equal to 5. So 1/5 is the answer. I hope you people have understood. So 1/5 of the total mixture is being taken out and the same amount of water is being added, so that the ratio from 5:3 gets converted into 1:1. Okay, I hope you people have understood this thing. Very easy. Coming to the next question. So this is a new category of question. Okay, so a container contains milk and water in 5:3 ratio. If 48 liters of mixture is taken out and replaced by water. Okay, so same sort of question. Then the new ratio of milk and becomes 3:5. And find the initial quantity. Okay, so how do you solve this type of question? So before as well we have already discussed this thing. So how do you solve this type of question? There are two methods to solve this. So if I clearly write this here, we have this original container. Okay, so original container, we have milk and water water ratio to be equal to 5:3. Okay, original container, that is the thing. And now after removing 48 liters from this, your milk and water ratio becomes 3:5. Okay, so not 3:5, sorry, that is not the transition, it is still 5:3. Why? Because not just because you have removed 48 liters of the mixture, it doesn't have it affect your total ratio, isn't it? Now let us assume you have a total mixture, we do not know the capacity. In that 5 parts of milk is there, 3 parts of water is there. Now we are taking 48 liters. Okay, now we are taking 48 liters of the mixture out there. So you're not removing water separately or milk separately, you're just removing 48 liters of mixture. So the ratio or the parts of milk is to water still remains the same. Okay, I hope this fundamental concept remains clear to you. Now after removing 48 liters as well, the milk is to water ratio will be still 5:3. But afterwards there is an addition of how much thing. So 48 liters of mixture has been taken out, and again 48 liters of water has been added. Okay, plus 48 liter of water, plus 48 liter of water. After adding 48 liters of water, your milk is to water ratio becomes 3:5. Okay, now after adding 48 liters of water, the ratio gets converted to 3:5. Okay, until and unless we are adding separate component, the original ratio remains the same. Okay, just because you have taken 48 liters of mixture, your ratio will not be affected, it will be still the same. There will be 5 amounts of water and 3 milk, 3 amounts of water. Now because you have added 48 liters of water, explicitly you have added water, your ratio gets differed. So 3:5 would be the new ratio. Now how do you solve this type of questions? Okay, so if you clearly see here the thing is 5:3, isn't it? 5:3. And now that means what can you infer from this? So 5:3 in the sense 5 parts of milk and 3 parts of water. So that is like 5/8 into 48, that is actually equal to 30 liters of milk, 30 liters of milk, and 3/8 into 48, that is actually equal to 18 liters of water. Okay, that is the original thing. Okay, that is the original thing. And what is the next thing that you can do now? Because this 48 liters, in this 48 liters, 38 liters of milk would be there, 18 liters of water would be there. So 5x, originally it is 5x, from the you are decreasing 30 liters of milk, and also from 3x you are decreasing 18 liters of water. There is 5x of milk initially, 3x of water initially. From 5x you are removing 30 liters of milk, from 3x you are removing 18 liters of water, and after that how much you are doing? You are adding 48 liters of water, and this becomes 3x by 5x. I hope you people have understood the derivation of this equation. Okay, so this is like this particular transition. Okay, this particular transition is this, and this particular transition is this. I hope you people have understood. So 5x and 3x are the original quantities of milk and water, and now from 5x you have removed 30 liters of milk, and from 3x you have removed 18 liters of water, because 5:3 is the ratio, it will remain the same in 48 as well. In 48, 5:3, so 5 parts are milk and 3 parts is water. What is 5 parts out of in 48? 5/8 into 48, that's equal to 30 liters. So 30 liters of milk, and 3x in the sense 3/8 into 48, that is 18 liters of water. Now 5x minus 30 would be the total amount of milk, and 3x minus 18, that is the total amount of water. Now that you have added 48 liters of milk water here, so what is the total quantity of water that is available now? 3x minus 18 plus 48. Now this ratio is basically nothing but 3:5, that is 3x by 5x. Okay, now if you solve this equation, what do you get from here? You get x and x gets cancelled, you get 5 into 5, that is 25x minus 150 is equal to 3 into 3x, that is 9x minus this is equal to 30, so plus 150. Okay, so this 3 into 30, that is 90. Okay, this is 90, this is 90. So you get this value to be equal to 16x would be equal to 240. You get the value of x to be equal to 50. I guess so, I'm not sure. Okay, x to be equal to, yeah, x to be equal to 50. Now what is the question they're asking? They're asking the original quantity. What is the original quantity? 5x plus 3x, that is equal to 8x. So the original quantity is 8 into 15, that is equal to 120 liters. This is the original quantity. I hope you people have understood. This is how it is. Simple thing. It's just that we need to write the equation properly and then solve it so that we get the correct equation, and from that we can get the correct answers. Okay. I'll erase this. So I hope you people have understood. This is the method 1. What about the method 2? Okay, I hope you people have understood the method 1. So it is somewhat complex, right? It is somewhat big. So what about the method 2? So it actually goes in the similar pattern. So what happens is, if you clearly see the question from the second transition, we have the milk like this. Okay, milk is to water, it is 5:3 only. Okay, it is 5:3. And after removing, 48 liters of water has been added. After adding 48 liters of water, the transition is the final ratio is 3:5. Okay, now what can you infer from this? You're adding water to the original mixture, so that your now new ratio is becoming 3:5. So you're changing the water, but you're not changing the milk. So again, you can come to the pivot that you can make the milk to be the constant value. Okay, so what do you mean is, so you can write the milk to water ratio as 5:3, that is originally there, and then finally we have 3:5. What are we doing now? We are adding 48 liters of water to transform the ratio from 5:3 to 3:5. So that means we are changing the quantity of water. We are not hindering the quantity of milk. So we can equate these two. Okay, how do we equate that? Take the LCM of 5 and 3. Okay, what is the LCM of 5 and 3? That is 15. So multiply this 5 by 3 and multiply this 3 by 5, so that you get that water milk quantity to be the same. And now because you have multiplied 3 to the milk quantity, you must also multiply that to the water quantity. So into 3 and here into 5. So what are your new ratios? So milk is to water would be 15:9, and then this is 15:25. Okay, now that we have equated the milk quantities, isn't it? Because we are not changing the milk quantity, we are only adding extra water, so the milk quantity should remain the same. What is the change that is happening? We are 16 parts. Okay, 16 parts of change is happening, and what is that? Equal to 48 liters, right? We are adding 48 liters of water, and there is a change of 16 parts, so 16x must be equal to 48, and you get x value to be equal to 3. Now what is the question they're asking? They're asking us to find the original quantity. Okay, how do you find the original quantity? So in this particular case, in this particular second box, so there's like, from first you have removed 48 liters of mixture, and then you have got a second box, and from that you have added 48 liters of water, you got the third box. Now this is basically, how do you get the quantity here? This is basically 15x plus 9x, that is equal to 24x. So this is 24 into 3, that is equal to 72, isn't it? So that is the original, that is in the second box. Now how did this come? This come after removing 48 liters of water from this particular first, right? Milk is to water 5:3. From that, if you remove 48 liters, you have got this. So add 48 to here, so you get the value to be 120 liters. So same question, same answer that we have got before in the method one. I hope you people have understood. So this is 172 is only for the second box. Okay, second situation. Your first situation, from there you have removed 48 liters, so you must add 48 liters to get the original quantity. So that is the reason we are adding 48. We get the final value to be equal to 120 liters. I hope you people have understood this thing. So the same thing I have written here, right? Coming to the next question. A container contains milk and water in 3:1 ratio. If 48 liters is taken out and replaced by 9 liters of water, then the new ratio of milk and water becomes 3:4. Find the initial quantity. That is the question. We'll solve it in a similar case. So what is happening? Initially milk is to water. What is the ratio? 3:1. Okay. So initially it is like this, and then from here you have removed 48 liters. So what is happening then? You are getting milk is to water. You'll be having the same ratio. Okay. 48 liters of mixture is being taken out, so there will be no change in the ratio. And after that you are adding plus 9 liters of water. Okay, plus 9 liters of water, plus 9 liters of water. You are adding water explicitly. Okay, now because you are adding some particular material separately, your ratio gets changed. What is this ratio now? That is 3:4. Milk is to water equal to 3:4. Now see this second change. Okay, so you must make sure, because you are adding a water, the milk quantity must remain the same. We are not adding or decreasing milk quantity, so the milk quantity must remain same. What is the milk quantity here? 3 parts. What's the milk quantity here? 3 parts. So the milk is already same. So what is the difference between the water quantity in the second box and the third box? That is 4x minus 1x, that is equal to 3x, and this is basically nothing but 9 liters, right? So from this you get the value of x to be equal to 3. Now what is the quantity here? That is 3x plus 1x, that is equal to 4x. So that is 4 into 3, that is equal to 12. That is the quantity here. And how did you get that? After removing 48 liters. So add 48 to this, you get the value of here, that is here 60 liters is the answer. Okay, I hope you people have understood. So we are taking the consideration of only the particular last transition only. From that we are getting the value in the second box, second situation. And how do you get the first situation? Whatever the subtraction that you have done, just add that to get the first initial amount. Okay, I hope you people have understood this thing. Very easy. It's all about applying our common sense and deriving the equation properly, so that you end up with the correct answer. Coming to the next question. A can contains mixture of two liquids, A is to B, in the ratio 7:5. When 9 liters of mixture are drawn off and that can is filled with B, the ratio of A and B becomes 7:9. liters of liquid A contained by the can initially was. Initially, what was the mixture of amount of A that was there? That is the question. So how do you solve this again? Again, the similar sort of thing. What is A is to B? That is originally it is 7:5, and from that 9 liters of mixture has been taken out. So will there be any change in the ratio? No. If the mixture is taken out, there will be no change in the ratio. And after that, 9 liters of water is being added. Okay. So what is the question saying? 9 liters of mixture has been drawn off and the can is filled with the B. Whenever they say like this without mentioning the explicit quantity of B, that means the same amount of water is being added. Okay. So water or B. Okay, it's not B anymore, water anymore, it's B. Okay, 9 liters of B. What would happen in this case? A is to B ratio becomes 7:9. Okay, so that is what they have mentioned. After adding 9 liters of B, the A is to B becomes 7:9. So are we changing the value of A? No. Are we adding A or subtracting A or removing A? No. So the A quantity must remain same. So A is in the second box, it is 7. A in the third box, it is also 7. So the A quantity is already same. Now what is the difference here? 5 minus 9 minus 5, that is equal to 4. And this 4x is basically 9, and from this you get the value of x to be equal to 2.5 liters. Okay. Now what is the value in the second box? That is 7x plus 5x, that is equal to 12x, and 12x is basically 12 into 2.25, that is equal to I guess this is okay, anyways, I need not write this all these things. 12 into 2.5, and then we have removed 9, so add 9 here, so that you get the original quantity here, that is equal to basically 36 liters. Okay, so 36 liters is the original quantity. And now what are they asking? A's quantity in the originally. So A says 7 parts and B is 5 parts. So A's part is 7 by, what is the total part? 7 plus 5, that is equal to 12. Multiply that by 36, you get the value to be equal to 21 liters. So A is actually 21 liters originally. I hope you people have understood. So it's all about connecting various small concepts together and then finally getting the required answer. Okay, so I hope there is no trouble in understanding these things. So the same thing I've written here. Okay, coming to the next question. A container contains 2 liquids A and B in the ratio 7:5. When 9 liters of mixture are drawn off and the container is filled with 9 liters of B, so the same thing. So they did not mention how much is being added. So it's the same thing. The ratio of A becomes 1:1. How many liters of A was in the there in the container initially? So the similar sort of thing again. So we have A is to B. Okay, A is to B. What is the value of A is to B originally? It is 7:5. Okay, and from this we are removing 9 liters of mixture. Okay, minus 9 liters of mixture. We have get this value to be 7:5 again, because we are removing the mixture, so there will be no change in the ratio. And afterwards we are adding the same amount of water. Okay, we are adding the same amount of water. What happens to this A is to B ratio? That happens to be 1:1. Okay. Now because you have added 9 liters of water, 9 liters of not water anymore, it's B. Okay, 9 liters of B. So because you're adding 9 liters of B, you're not changing any A, you're not adding A or not subtracting A. So the value of A must remain the same. So what is the value of A in the second? It is 7. What's the value of A in the third? It's 1. So we must equate. So 7:5 is the original one, and then we have 1:1 is the new one. So multiply, the AM column must be same. So multiply by 7 here. So into 7, you get this value to be 7:5, and we have 7:7. Okay. Now what is the difference? We have equated the A's value. 7 parts in the second box, 7 parts in the third box. Only difference should be here. That is equal to 2x, and that is basically equal to 9. From this you get the value of x to be equal to 4.5. So 4.5 liters of B has been added to the particular mixture, so that from 7:5 we have got the value to be 1:1. Now what is the question they have asked? They have asked to find. So they have asked us to find just a minute. So yeah, how many liters of A was there in the initial? So now that we have got the value of x, that is 4.5, what is the value here in the second box? That is 7x plus 5x, that is equal to 12x. So 12x equal to 12 into 4.5, and also plus what that you need to do? You have removed 9, so add that 9. So if you do that, you'll be getting the value to be equal to 63 liters. Okay, 63 liters. Now how do you get the value of A? So A is 7 parts out of 12 parts out of 63 liters. Okay, so the total quantity is 63 liters. We have got that here. So 7 by 12 into 63, we'll be getting this value to be 147 by 4 liters. So this is the quantity of A original in the original case. Okay, I hope you people have understood. So all these concepts revolve around the same thing. Like you need to equate the part that has not been changed or not been affected. Okay, so in the previous questions that we have seen so far, only one particular material is being added, only B is being added or is being subtracted. So the other quantity, that is A, remains the same. So we need to equate that particular column to a particular number. So that is the reason we are taking LCM, and we are equating that to a particular number, and we are taking the difference of the next the other column and equating that to the quantity that's being added. From that we are are getting the each part value, and that we are using to calculate the original quantity, and we are getting the A share and B share in that particular original quantity. Okay, I hope you people have understood. The pattern to solve this question is very clear. There's no place for confusion or anything in this. Coming to the next question. So in what proportion may three kinds of tree prices at 80 rupees per kg, 70 rupees per kg, 50 rupees per kg be mixed to produce a mixture worth rupees 60 per kg? Okay, so how do you solve these questions? So in the question it's been clearly mentioned 80 rupees per kg and 70 rupees per kg. So all these rupees are per kg. I'm not writing it again. So 50 rupees per kg, and now so that you get a mixture of 60 rupees per kg. So what is the technique to solve this? Is can you put 60 here? You all remember the fundamentals of mixture and delegation, right? So whatever the prices you have, you'll also put the price in the between, and you'll be getting the quantities in the down, right? Now can you put 60 here? That is the question. We cannot put 60 here because 60 does not come in these two range, 70 and 80. Will 60 come in between 70 and 80? No. That is the reason we'll not put 60 there. So your whole task will be around putting the 60 in the correct place, or putting the final result in the correct place. So where can you put 60? Can you put 60 here? Yes, because from between 50 and 70 we get 60. Now that we have put the prices, how do you get the quantity? Just subtract this. So after subtracting this, what do you get? So 60 minus 50, what do you get? You get 10 here. And 60 minus 70 minus 60, what do you get? You get 10 here. Okay, so 10 is to 10. So what is the ratio? That is 1 is to 1. What is this? This is B, this is C, this is A. Let us assume. So this is B is to C ratio. Okay, and what is the other thing? Where is the other thing that you can place 60? Can you place 60 between 50 and 80? Yes, because 60 comes in between 50 and 80. So you can even put 60 there. So I'll just erase this stuff. Or I'll do one thing. I'll just write 60 here itself. Okay, and then I'll write these things here. So I'll write again this particular thing here. Okay, A I'll take here, that is 80 rupees. C I'll take here, that is 50 rupees. So I can put 60 here as well, right, in the middle. So because 60 comes in between 50 and 80. So what happens is, so I'll take the difference. So if I take the difference, what do I get here? I get 20 rupees here and I get 10 rupees here. What is the ratio? This is 10 is to 20, that is equal to 1 is to 1. And what is this? This is basically nothing but A is to B. We have got B is to C ratio in the first thing to be 1 is to 1. We have got A is to B ratio in the second thing to be 1 is to 1. So how do you calculate A is to B is to C ratio? A is to B is to C ratio is wherever you have the final values, common values, add them. So we have A to be 1, that is done. But in the first we have B to be 1, in the second we have B to be 1. So add them both. So 1 plus 1, that is equal to 2, and we have C value here, that is 1. So A is to B is to C ratio will be equal to 1 is to 2 is to 1. I think I've done a blunder somewhere. 1 is to 2, and this is okay. So yeah, 10 is to 20, right? So this is not 1 is to 1, this is 1 is to 2, isn't it? So 2 plus 1, that is equal to 3. So here it is 3. 1 is to 3 is to 1 should be the okay. Yeah, 1 is to 3 is okay. This is not sorry, yeah, that is what I was wondering. So this is not B, right? This is C. So this is 1 is to 2, this is C, this is C. So you must be even careful evaluating these things. So in the second first ratio we are dealing with B and C. In the second ratio we are dealing with A and C. Okay, so C's value is actually 2, not B's value. So we have C's value to be 1 in the first ratio, C's value to be 2 in the second ratio. To add them up, so we get 1 is to 1 is to 3 as the perfect answer to A is to B is to 3. Okay, I hope you people have understood. So A is the thing that is not common, B is the thing that is not common, only C is the common thing. So we have added the C's value in the first ratio and the second ratio. I hope you people have understood this thing, and we have got this value to be 1 is to 1 is to 3. Coming to the next question, in what ratio a person makes 3 kinds of wheat costing him 1.20 per kg, 1.44 per kg and 1.74 per kg, so that the mixture may be worth 1.41 per kg? Okay, similar sort of question. So you'll be having 3 values here, 1.20, and then you'll be having the next value to be 1.44, and you have the next value to be equal to 1.74, and you want the final value to be equal to 1.41. So first decide where are you going to put 1.41. So let us name these to be A, B and C. Can we put 1.41 between A and B? Yes, we can, because we have 1.41 between 1.20 and 1.44, right? So we can put 1.41 here and take the difference now. So what do you get after you take the difference? You get 0.03 here and you get 0.21 here. Okay, so what is this? How does this simplify to 0.03 is to 0.21? This is basically nothing but 3 is to 7, and you get this value to be equal to sorry, this is basically 3 is to 21. So 3 is to 21, this is basically nothing but 1 is to 7. Okay, and what is this? This is basically A is to B. So it's very important that you figure out what parts are there, like you should name them properly. Now what is the next thing? Where can you put 1.41 again? So you can put between A and C as well. A is 1.20, C is 1.74. You can put 1.41 there as well. So you can write A here, you can write C here, you can put 1.20, you can put 1.74 here, and between you can put 1.41, and now you can take the difference. So what do you get after you take the difference? So you get the value of difference to be here as 0.33, and you get the value of difference here as 0.21. So this is basically that 3 is to 21. This is basically 11 is to 7. Okay, and what is this value? This is basically A is to C value, and we have got A is to B in the first ratio, A is to C in the second ratio. What is the common thing? A. So A is common, so add them up. So A is to B is to C value would be, so A is common, A is 1 in the first ratio, 11 in the second ratio, so add them up. We get 12 is to B value is 7 and C is to 7. So 12 is to 7 is to 7 is the perfect answer to this question. I hope you people are able to understand. So this basic part of mixture and delegation concept we all know. We all know all these things. So it's just that you need to decide where are you going to put the mean value or the final value, and then solve the question accordingly. So the same thing I have written here. A is to B is to C value will be 12 is to 7 is to 7. Okay, so I hope you people have understood this thing. Coming to the next question. In what ratio a person makes 3 kinds of tea costing him 60 rupees per kg, 95 rupees per kg, 100 rupees per kg, so that the mixture when sold at 96 rupees per kg yields a profit of 20%. Okay, so it's very important that you again remember the fundamental concepts of mixture and delegation. What is that they're given in the question? 60 rupees per kg and 95 rupees per kg and then 100 rupees per kg, right? These are the 3 values that have been given. So let us assume this is A, B, C. What are these actually? These are the cost price. Okay, these are the cost price. Now in the question they have given the mean price or the final price that is equal to 96 rupees per kg, and this is nothing but selling price. Okay, it's very important that you classify them properly. So A, B, C cost price has been given and they have been given the selling price. Okay, so it's very important that you convert the selling price into cost price. Okay, so you must have all of them into the similar category. It's not that you put cost price in the top and selling price in the middle. That's not going to work. You must put all of them in SP or all of them in the CP. Just because we have got 3 values in CP, we'll also convert this SP into CP. How do we do that? They have been given this selling price is 96 rupees after selling it at a profit of 20%. So how do you get CP? So CP is basically nothing but SP into 100 by 100 plus profit percent. Okay, 100 plus profit percent. This is very important formula and we all know this basic formula. So when you substitute that, we get CP value to be equal to SP is 96 into multiplied by 100 divided by 100 plus 20, that's equal to 120. So if you solve this, you get the value of SP to be equal to CP to be equal to 80 rupees. So 80 rupees per kg should be the mean price or the final price. So can you put 80 between A and B? Yes, we can put 80 rupees between here. And if you take the difference now, so what would be the difference? You get here 15 and you get here that to be equal to 20. So this ratio is basically 3:4. Now that is done, we have got the first ratio, that is between A is to B. And can we put 80 between B and C? No, B value is 95, C value is 100, so you cannot place 80 between them. But you can place 80 between A and C. So you can take A value here, C value here, A is 60, C is 100, you can put 80 here. And what do you get the difference? You get the difference to be equal to 20 here, you get the difference to be equal to 20 here. So the ratio is 1:1. And what is this actually? A is to C. So we have got A is to B in the first ratio to be 3:4, A is to C ratio in the second to be 1:1. So A is common, so add them up. 3 plus 1, that is equal to 4. So A is to B is to C would be equal to 4:4:1. This is the final answer, right? So I hope you people are able to understand. So the fundamental concept is of the mixture and delegation. What are the prices you are taking in the top? The same price category must also be in the middle, okay, or the mean price or the final price. It must not be like you're dealing with the CPs in the top and SPs in the bottom, in the middle. That's not going to work. SPs or CPs in the top and the middle, and then finally in the bottom you'll be having the quantities ratio. Okay, so that's a fundamental concept of mixture and delegation actually. So the same thing I've written here. The final ratio is 4:4:1. Coming to the next question. Similar sort of question. So mixture 3 kinds of tea costing him 20 per kg, 24 per kg and 30 per kg, and is selling at the mixture at 20 rupees, 20% at 30 per kg. Okay, the selling price has been given 30 per kg and the profit is 20%. So how do you get the CP? SP into 100 plus by 100 plus profit, you get the value of CP to be equal to 25 rupees. Now insert 25 in the right place. Between 24 and 30 you can insert, you get the quantity of B is to C to be equal to 5:1, and you can put 25 in between 30 and 20, you get the value of A is to C to be equal to 1:1. 1. So what is the common thing here? C. So add C here. Okay, so you get 1:5:2 is the final A is to B is to C ratio. But what is the question they're asking? How many kgs of second variety will be there in the mixture if 2 kgs of third variety is there? So what is the final ratio? We have got 1:5:2, that is the final ratio, and we have the third quantity, that is C value, to be equal to 2. So 2 parts is actually equal to 2 kg, so 1 part will be equal to 1 kg. And what is the value of the B, that is second material, that is the question they are asking, right? Second variety, that is equal to 5x. So 5 into 1, that is equal to 5 kgs of B is available. Coming to the next question. Container A and B contains mixture of milk and water in 5:3 and 3:4 respectively. If both mixture are mixed together, find the new ratio of milk and water. That is the question. So how do we solve this? So there are two methods here. So milk is to water, okay, milk is to water, that is equal to 5:3, and plus milk is to water, and that is equal to 3:4, and you need to find the final mixture. Okay, so both are being added. So how do you do this? So what's the method 1? So method 1 is, so what is the method 1? Take m by w, okay, m by w, and what's the milk in the first ratio, in the first 5. So 5 divided by what's the total? 8, plus what's the milk in the second ratio? That is 3, divided by how much it is? 3 plus 4, that is equal to 7, divided by what is water in the first ratio? 3, divided by what is the total? 8. So plus what is the water in the second ratio? Parts of water in the second ratio? 4, divided by what's the total parts? 7. So if you solve this, you get the value to be equal to 59 by 53. Okay, this is the one method to solve this question, but it is not really preferable. We'll be solving with the method 2. What is the method 2 is telling? So first write the milk is to W ratio, that is 5:3, and we have 3:4. Okay, that is what we have written. And now what is the total parts here? It is 8, and total parts here is 7. 5 plus 3 8, 3 plus 4 7. Equate them. Okay, so we multiply them with 7 and we multiply this with 8. So multiply this 7, it's 7 and 8 and 8. What is the ratio that you are going to get from this? You get 35. Okay, you get 5:7, that's 35, is to 7:1, 21, and we get 24 is to 32. So now add them. Okay, add milk and water. So 21 is to 32, that is equal to 53, and we have 35 plus 24, that's equal to 59. So this is the milk is to water ratio, final milk is to water ratio. I hope you people have understood. It's very easy. It's just that you need to equate the total quantities and then add them individually to get the individual ratios. Okay. So this is a very good question and standard question. Coming to the next thing. Container A and B contains mixture of milk and water in 7:5 and 5:3 respectively. Both mixture mixed together, find the new ratio of milk and water. Same thing. So milk is to water in the first one is 7:5. Milk is to water in the second is 5:3. Add them first. So 7:5. Okay. So it's like this. Milk is to water, 7:5, and then we have 5:3. Okay, so this is what is being given in the question. What is the total parts here? 12. What's the total parts here? 8. So you need to equate this value. So multiply it with 2 here, multiply it with 2 here, and multiply it with 3 here. LCM of 12 and 8 is basically 24, right? So to get 24 from 12, multiply by 2 in the first, and to get 24 from 8, multiply by 3 in the second. So multiply by 2 here, multiply by 2 here, multiply by 3 here, multiply by 3 here. So what you get here? You get 14 is to 10, and you get 15 is to 9. So now add them up. Okay, so you get 29 here is to 19. So this is the ratio of milk is to water, final ratio. Okay, so 29 is to 19 will be the final ratio. I hope you people have understood this thing. Coming to the next question. Two vessels A is to B A and B contain mixtures of milk and water in the ratio 4:1 and 9:11. They are mixed in the ratio 3:2. Find the ratio of milk and water in the resulting mixture. So far they are mixed totally. Now they are mixing in 3:2 ratio. So how do you do solve these two questions? These questions actually. So we have milk is to water to be 4:1, and we have milk is to water in the second to be equal to 9:11. And now these are being mixed in the 3:2. So we have 3 parts here, 2 parts here. So how do you solve this question? Again, similar sort of approach. Milk is to water, we have 4:1, and we have 9:11. Now what you do is first take the total parts. What is the total parts here? It's 5. The total parts here is 20. So you need to multiply by 4 here to get 20. So multiply by 4 and multiply by 4 here, right? And now multiply by 3, because we have 3 parts in the total for the first one. So multiply by 3 as well. Multiply by 3 and multiply by 3, and we have 2 in the second. So multiply by 2 in the second ratio. That's all you need to do. First thing, take the total, equate the total, and then multiply the individual ratio parts. So you get this ratio. What do you get? The first one to be equal to milk is to water to be the first one. You get 48, and water to be equal to 12, and the second one you get 18 is to 22. Now you add them up. Okay, so what you get from here? You get 66 is to 34, and this solves to be equal to 33 is to 7. So this would be the final answer. Okay, so if you mix 3:2 ratio of the first and second container, you get the final value to be equal to 33 to 70. I hope you people have understood this thing. So coming to the last question. So two vessels A and B contain milk and water in 7:5 ratio and 17:17 respectively. In what ratio mixture from two vessels should be mixed to get a new mixture containing milk and water in the ratio of 5:3? Okay. Now we have got the final ratio, that is 5:3. Now you need to figure out how much part ratio you are going to mix the first container and the second container. So how are you going to solve this question? Again, it's very easy. So we have milk is to water. What is it? 7:5. And we have milk is to water in the second container, that to be equal to 17:7, and we get the final milk is to water value to be equal to 5:3. So how do you do this? Write the values again. Okay, milk and water, we have 7:5. What's the total here? That is 12. And we have 17:7. What's the total here? That is equal to 24. And we have the final output to be 5:3. What's the total here? 8. Now again equate these totals. Okay, so LCM of 12, 24, 8. What is it? 8. So multiply into 2 here, into 2 here, into 2, into 2, and multiply into 3 here, into 3, into 3. Okay, now that we have done this, now how are you going to get this particular thing? So take individual columns. Okay, so if you take this particular milk column, if you take the milk column, we have originally 14 and 17 here, and between we have 15. Okay, finally we in the first container we have 14, in the second container we have 17, finally we have got 15. So how many quantities, how much quantities? You just need to subtract, so you get 22:1. So this is the ratio, 2:1 is the final answer. That is enough. You need not bother about the second column. If you would like to solve through the second column, you can even do the same thing. So we have 10 in the first, and we have second, in the second we have 7, right? 10, 7, and finally how much we have? 9. So again take the difference. So if you take the difference, we have 2:1, right? It's the same ratio, isn't it? So if you bother about only one column, work on only one column, that's more than enough. You need not solve it further. Okay, I hope you people have understood. So you must mix this in 2:1 ratio so that you get the final answer to be 5:3. Okay, I hope you people have understood this thing. Very easy stuff. So we have seen good number of problems so far. I hope you people have understood every approach and every type of question. So we have covered almost all models of mixture and irrigation. It's all up to you to solve. Keep practicing more number of problems in this particular topic and get good command on this particular topic. Okay, so thank you for watching. Stay tuned.